Hello and welcome to Menalize TV once again. My name is Rejoice and today our lesson is going to be based on sets. So when we talk about sets, set is basically a number that cannot be reduced any further to remove the square root. For example, when we take root of 25, we can simplify it further to get 5. But when we take root of 2, we cannot simplify it to get a simple whole number. So it gives us 1.414 and root of 3 gives us 1.732. So here we can say that root of 3 and root of 2 are sets or irrational numbers, but root of 25 here is a rational number which is not a set. When we take these numbers written here, root of 2, root of 3, root of 5, root of 7 and root of 11, they cannot be reduced any further to remove the square root. So they are called irrational numbers, generally known as sets. So when we take a number that is in a square root that cannot be reduced any further, then we say it is simplified. When we take root of 8, it can be written as root of 4 times 2, which is equal to root of 4 here times the root of 2 here. And we know that root of 4 is equal to 2. So we cannot simplify the root of 2 any further. But here we know the root of 4 is equal to 2. So our answer here then becomes 2 root 2. So this is then the simplified form of root of 8. Therefore, root of 8 is equal to 2 root 2. Root of 75 can be written as 25 times 3, which is also equal to root of 25 times root of 3. And we know that this root of 25 can be simplified, which gives us 5. But this root of 3 here cannot be simplified again. So we get 5 times the root of 3, which is equal to 5 root 3. So root of 75 is now equal to 5 root 3. Properties of sets. So these are the properties of sets. The first one, when we take root of a all squared into brackets all squared, it is then equal to root of a times root of a, which is equal to a. This is because the square root sign here cancel the square root sign here, giving us the a. We come to the second property here. The root of a squared is equal to a. This is because the square root sign here will cancel this square here, giving us a. So let's come to the third property. When we have root of a all over root of a, it is also equal to root of into brackets a over a. We can add or subtract two sets when they are the same. For example, a root c plus b root c are the same, so we can add or subtract them. So a root c plus b root c is equal to a plus b all root c. So when we have something like this, the numbers in the square root are not the same, so we cannot add or subtract them. Let's take an example of addition of sets. So here we know that two sets can be added when the number under the square root sign are the same. So here we know that the numbers under the square root sign here are all the same. So therefore we can add them. So this is how we do it. We add the 3 to the 6 here, getting 9. But since these numbers are the same, we just bring it. So it becomes 9 root 5. Then we come to subtraction of sets. So as I explained earlier here, we can only subtract two sets if they are the same. So here they are the same because the numbers under the square root sign here are all the same. So we just subtract the b from the a, which is a minus b root c. So let's take an example. Here is an example of subtraction of sets. So it is also the same as the addition of sets, just that the operation is different. So here we subtract the 2 from the 7, which is then equal to 5 root 3. So here we come to multiplication of sets. So when we talk about multiplication of sets, it is just the same as multiplying the numbers that are equal. So here the number in front will multiply the number in front here, and the number under the square root sign will also multiply the number under the square root sign here. So here we have 3 times 5 times root of 7 times 11, because they are all under the square root sign. So it is the same as 7 times 11 here under the square root sign here. So here our answer is equal to 15 root 77. So this is all about multiplication of sets. Let's come to rationalization of sets. So when we talk about rationalization of sets, we just wanted to make the denominator, which is an irrational number, to become a rational number. So when we want to do that, we just multiply both the numerator and the denominator by the denominator here. So when we multiply this, we get a times root of b, which is equal to a root b, and then root of b times root of b is equal to b, because the square root signs are cancelling each other. So we get b. Let's take 3 over root of 7. We want to make this root of 7 to become a rational number. By so doing, we multiply the numerator and the denominator by this irrational number, which is root of 7 here. So we have root of 7. Multiply the whole thing by root of 7 all over root of 7. So here we get 3 root 7 all over 7. So thank you so much for watching this lesson. Remember to subscribe to this channel, Menalite TV, for more updates. Thank you.
Bye.
Bye.